Hello everyone. Welcome to HNM Technologies online training program. Artificial intelligence is no longer just a technical capability. It has evolved into a strategic asset that determines the long-term competitiveness of organizations. In earlier decades, companies gained advantage through access to capital, supply chains, or market positioning. Today, competitive differentiation increasingly depends on how effectively organizations leverage data and artificial intelligence. AI strategy refers to the deliberate planning and structured implementation of AI initiatives to achieve measurable business outcomes. It ensures that AI adoption is not random experimentation but a focused transformation aligned with enterprise goals. Many organizations mistakenly begin AI adoption by focusing purely on technology. They invest in tools, hire data scientists, or experiment with pilot projects without clearly defining the business value they seek. This approach often results in isolated AI experiments that fail to scale. A true AI strategy begins with business objectives. Whether the goal is reducing operational cost, increasing revenue, improving customer experience, or enhancing risk management, AI must serve these strategic objectives rather than operate independently. An effective AI strategy integrates three dimensions: business alignment, technological capability, and organizational readiness. Business alignment ensures AI projects solve real problems. Technological capability ensures the infrastructure, tools, and data pipelines are sufficient. Organizational readiness ensures leadership support, cultural adoption, and skill development. If any of these three elements are missing, AI initiatives may struggle or fail entirely. Another critical aspect of AI strategy is prioritization. Not every department requires AI transformation simultaneously. Enterprises must identify high-impact areas where AI can deliver measurable value within a reasonable timeframe. Quick wins build confidence and demonstrate ROI, which supports further investment. Strategic sequencing of AI initiatives ensures sustainable adoption rather than overwhelming the organization. Finally, AI strategy must be viewed as a long-term journey, not a one-time transformation. Technologies evolve rapidly. Data ecosystems expand continuously. Regulatory environments change. Therefore, AI strategy must be dynamic and adaptable. Organizations that treat AI as a strategic capability rather than a temporary innovation trend are more likely to sustain competitive advantage over time. The foundation of successful AI implementation lies in identifying the right use cases. Many AI projects fail not because of poor models but because they attempt to solve the wrong problems. High-impact AI use cases emerge where three factors intersect: business value, data availability, and technical feasibility. Without this intersection, AI initiatives become expensive experiments rather than transformative solutions. The first step in identifying use cases is understanding business pain points. These may include high customer churn, operational inefficiencies, fraud losses, supply chain disruptions, or inaccurate forecasting. AI should address problems that significantly affect revenue, cost, or customer satisfaction. Projects that generate measurable impact are more likely to secure leadership support and long-term funding. Data readiness is equally critical. AI systems require large volumes of clean, reliable data. Organizations often underestimate the effort required to prepare data for AI applications. Before selecting a use case, companies must evaluate whether relevant historical data exists, whether it is structured or unstructured, and whether it is governed by compliance constraints. If data is insufficient or unreliable, even the most advanced AI models cannot deliver value. Feasibility assessment involves technical evaluation. Some use cases may require capabilities that exceed the organization's current infrastructure or expertise. For example, deploying real-time recommendation systems requires low-latency architecture and scalable APIs. Organizations must assess whether they have the technical maturity to support such initiatives or whether phased implementation is required. Finally, ROI estimation and risk evaluation are essential. AI initiatives involve costs related to infrastructure, talent, and maintenance. Organizations must project potential financial returns and compare them with investment requirements. Additionally, regulatory, ethical, and operational risks must be considered. High-impact AI use cases balance value potential with manageable risk exposure. Technology alone does not create transformation. Organizational culture determines whether AI initiatives succeed or fail. An AI-driven organization is one where data-informed decision-making becomes the norm rather than the exception. Leaders and employees must trust data insights and integrate them into everyday processes. Leadership commitment is essential. AI transformation requires cross-departmental coordination and long-term investment. Without executive sponsorship, AI projects may remain confined to innovation labs without scaling enterprise-wide. Leadership must articulate a clear vision for AI adoption and communicate how it aligns with strategic objectives. Establishing an AI Center of Excellence, (CO), is a common organizational model. A CO centralizes expertise, best practices, governance standards, and technical infrastructure. It supports different departments in implementing AI use cases while maintaining consistency in architecture and compliance. This structure balances innovation with governance. Cross-functional collaboration is equally important. AI projects require cooperation between data scientists, software engineers, business analysts, compliance teams, and operational managers. Silos hinder innovation. An AI-driven organization promotes interdisciplinary collaboration to ensure models address real-world constraints. Continuous learning and skill development sustain AI maturity. Technologies evolve rapidly, and employees must continuously upgrade their knowledge. Organizations should invest in AI literacy programs for non-technical staff and advanced training for technical teams. Building internal capability reduces dependency on external vendors and strengthens competitive positioning. AI adoption requires substantial investment. Infrastructure costs include cloud computing resources, GPU clusters, storage systems, and security mechanisms. Talent acquisition is another significant expense. Skilled AI engineers, data scientists, and MLOP specialists command competitive salaries. Organizations must plan investments carefully to avoid unsustainable expenditure. Operational costs extend beyond initial deployment. Models require monitoring, retraining, and updates. Data pipelines must be maintained. Security audits must be conducted. These recurring costs should be included in ROI calculations. Short-term budgeting without accounting for lifecycle costs may result in underfunded projects. Measuring AI ROI can be complex. Unlike traditional IT investments, AI benefits may not always be directly measurable in revenue terms. Some benefits appear as cost reduction, improved accuracy, faster decision-making, or enhanced customer experience. Organizations must define quantitative metrics aligned with each AI initiative. Long-term value creation often outweighs immediate financial gains. AI can create strategic capabilities such as predictive insights, automation frameworks, and innovation pipelines. These capabilities enable faster response to market changes and improve resilience. ROI measurement should therefore consider both direct and indirect value. Strategic investment planning includes phased rollout. Instead of large upfront investments, organizations may adopt pilot projects to validate impact. Successful pilots justify scaling investments. This iterative approach reduces financial risk while maintaining momentum in AI adoption. As AI systems influence critical decisions, governance becomes essential. AI governance frameworks ensure that models operate ethically, transparently, and in compliance with regulations. Without governance, organizations face reputational, legal, and operational risks. Ethical guidelines must address bias, fairness, and inclusivity. AI systems trained on biased data may produce discriminatory outcomes. Organizations must implement bias detection tools and fairness audits. Transparent documentation of training data and model decisions enhances accountability. Risk management protocols evaluate potential consequences of AI deployment. For example, financial models influencing credit approval must undergo rigorous validation. Healthcare AI systems require compliance with medical standards. Governance structures define approval workflows before production deployment. Regulatory compliance is increasingly significant. Governments worldwide are introducing AI regulations focusing on transparency, privacy, and accountability. Organizations must align AI practices with evolving legal frameworks to avoid penalties and maintain trust. Responsible innovation balances technological advancement with societal responsibility. Organizations that prioritize governance not only reduce risk but also strengthen brand credibility. Ethical AI practices enhance customer trust and long-term sustainability. The future enterprise will be AI native, meaning AI capabilities will be embedded into core operations rather than treated as add-ons. Decision-making will increasingly rely on predictive insights. Automation will streamline processes, reducing operational inefficiencies and freeing employees for strategic tasks. Innovation cycles will accelerate as AI tools enhance research, design, and development processes. Generative AI systems will assist in product prototyping, marketing content creation, and customer engagement. Enterprises will shift from reactive operations to proactive intelligence-driven strategies. Competitive differentiation will depend on AI maturity. Organizations with integrated AI ecosystems will respond faster to market changes. They will personalize customer experiences at scale and optimize resource allocation dynamically. AI-driven enterprises will outperform competitors relying solely on traditional analytics. However, innovation must remain sustainable. Rapid AI adoption without governance or strategic planning may create operational instability. Enterprises must balance experimentation with disciplined implementation. Continuous evaluation ensures AI initiatives remain aligned with evolving business objectives. Ultimately, AI strategy transforms enterprises not just technologically but culturally and operationally. The organizations that thrive will be those that combine technical expertise, strategic foresight, ethical responsibility, and continuous innovation. Throughout this session, we explored artificial intelligence not just as a technical tool, but as a strategic transformation engine. We began by understanding that AI strategy must align with business goals. Technology without direction leads to fragmented initiatives. A clear AI roadmap ensures that projects generate measurable impact. We examined how identifying high-impact use cases is essential. AI should address real business pain points. Data availability, feasibility, and ROI estimation must guide project selection. We discussed the importance of building an AI-driven organization. Leadership commitment, cross-functional collaboration, and a culture of data-based decision-making are critical for sustainable transformation. Investment planning and ROI measurement ensure that AI initiatives remain financially viable. AI projects should deliver both immediate value and long-term strategic advantage. We emphasized governance and responsible innovation. Ethical AI practices, bias monitoring, and regulatory compliance protect both organizations and society. Finally, we explored how AI-native enterprises will redefine industries. Automation, predictive intelligence, and AI-powered innovation will shape the future of business. This topic elevates AI understanding from technical implementation to executive strategy. At this stage, learners are no longer just AI developers. They are prepared to think like AI architects, AI strategists, innovation leaders. Over the course of this program, we have covered the complete journey of artificial intelligence. We started with the foundations of machine learning, understanding supervised learning, evaluation metrics, and real-world workflows. We moved into deep learning and neural networks, exploring how modern AI systems learn from complex data. We studied MLOps and deployment strategies to understand production-grade AI systems. We explored generative AI and large language models, which represent the cutting edge of AI innovation. We designed end-to-end AI systems and understood how architecture, scalability, and security shape enterprise applications. Finally, we examined AI strategy and enterprise transformation, the level at which AI reshapes entire organizations. This program bridges technical depth with strategic vision. You are now equipped not only to build AI systems, but to design, deploy, scale, and strategically lead AI initiatives. Artificial intelligence is not just the future of technology. It is the foundation of the next generation of innovation. Thank you for attending this session.